Welcome, final session of the day. Hi. Who is going to the Christmas dinner tonight? Shall we just go? Maybe? I won't hold you for long. So, but this is an important topic. Who is building distributed systems in this room? Yeah, good. So, for you, it will be relevant. For those who don't build distributed systems, for you, it will be relevant in the nearest future because you will be building distributed systems. I don't see like there were monolith distributed system. I don't see monolith winning. So it's like Docker Swarm. I think it will lose some time in the future. Nevertheless, even in monolithic systems, the observability is important, and we will talk through this soon. Those who've been here or listened to the virtual conference, I gave a talk in NDC last year. And the talk was called Trace, Open Metrics, Open Telemetry, Open Tracing. Are we there yet? Because there was a lot of things going on at the time. And 2020, or 2019 maybe, or beginning of 2020, Open Tracing said, we're giving up, we are joining with Open Sensors, and we are moving forward to Open Telemetry. And you come to Open Telemetry website and say, we are in alpha stage, there is nothing there yet. So you're kind of lost. But Open Tracing worked, and it still works. And I gave some advice to people. The video is now on YouTube, so if you are in the Open Tracing world, you can still get some benefit from it. So we weren't there yet in 2020, but time flies, so we are in 2021 in what is OpenTelemetry. OpenTelemetry aims to replace certain things and consolidate them together in one API, one SDK, and even more. So what they want to do. First, they provide a way to collect traces and metrics in log in kind of standard way. And it's all described, the spec is online, you can go read it and stuff like that. And it goes across all the platforms that exist, at least it's supposed to. They want to support as much as possible drop-in instrumentation. It means that you install certain library, you write a couple lines of code, and it just gets instrumented, especially for standard components like ASP.NET Core, gRPC. They have instrumentation for SQL Server, they have instrumentation for Stack Exchange Redis and stuff like that. There are a bunch of contrib libraries that instrument even more. And all of that you can do by just installing a NuGet package, telling OpenTelemetry I want to instrument it, and it will work. What it actually delivers, we will talk about this in a moment. And it's open source and vendor neutral. So OpenTelemetry is not a company. It's a standard and it's a consortium of like, it's a group of people, they have a committee and stuff, which design the spec and the APIs and decide how it should look like, and all the libraries that are built for all the platforms need to comply to that. Which means that there is no vendor backing it. So if you compare it to Vector, which has a similar aim, but it doesn't focus on metrics and traces necessarily, it is kind of more generic. It's a company and it's backed by, it was bought by Datadog without earning a cent of money, but nevertheless. OpenTelemetry is not like that. For example, OpenTelemetry for .NET was built with a significant contribution from Microsoft. There were several engineers working there, and they're still in a group of maintainers and approving pull requests. So OpenTelemetry in 2021, it's quite different from what was there before. I took this from the OpenTelemetry website itself, so it doesn't mean that all of that is in OpenTelemetry.net. It's the OpenTelemetry itself, how they explain what they have. For tracing, everything is stable except the collector, which is experimental. And what collector is, I will explain later. I tried the collector, it actually works. Metrics. With metrics, the story is pretty funny because OpenTelemetry for .NET 0.1 was released beginning of this year, and it was out of beta. However, they removed all the metric code, which was sad because I contributed to it as well. And they build it from scratch, and they build it in a completely different way. When the API got feature freeze, the SDK is still experimental, but Microsoft did something interesting. They actually built metric support inside the system diagnostic libraries, the abstraction. I will show you how it works. The protocol, however, is stable, and protocol is something we need to talk about in a short moment. Collector, again, is experimental. I'm not sure if collectors, like some collectors, I think collection of metrics works as well. It's just the number of exporters maybe is not complete. Logging, that's ambitious, right? We have tons of different styles of logging. I mean, we moved to structured logging, luckily, right? Microsoft provided their own logging abstraction library, and kind of a nice thing to like drop in things in logging. They didn't manage to kill Serilog, although people expected them to. I use Serilog personally, plugging into the Microsoft logging abstractions and stuff. However, OpenTelemetry aims to kind of consolidate this as well, so it provides the ability for applications to log in a uniform way across different platforms and shovel it to the centralized logging system over the uniform protocol, which replaces all the different variations of protocols. Because think about all the syncs you have for Microsoft Login and Serilog, there are quite a few of them, and each one of them requires different configuration. And essentially, all of that can be theoretically replaced by a single collector. So, I won't touch on the protocol just yet. I won't touch on the collector. We will get to this by the end of the talk. What I want to show is, because I started to instrument my libraries and my applications, some of the apps that were built are instrumented with open tracing. Most of them are instrumented with Prometheus metrics. And then when we built a new app, we said, okay, let's try OpenTelemetry. And we started to instrument it. It didn't go really well. And I built this library that I talked about earlier today, event sourcing library for .NET. And I struggled quite a long time to go through all of that and reading all the documentation and stuff like that. So what I found and what I've done, I would like to share it with you today so you can basically save some. Like maybe if I save 1 hour for each one of you, it will be a lot of good environment effect. Collector here. No, let's skip. This is like, it's supposed to be a demo, right? So now I need my bloody glasses. Small screen. So what I have here, I have already added some OpenTelemetry instrumentation, which doesn't instrument anything at all just yet. It's just the basic stuff. There are a couple of packages here. You can see it here. One is called OpenTelemetry Exporter OpenTelemetry Protocol. We will talk about this later. And those two I use at the moment. No, none of those I actually use. The implicitly installed OpenTelemetry SDK, I think that's what I use. And extensions for .NET Core to like register things with a container. So to add tracing, maybe I'm going a little bit ahead of the train, but we will see what tracing is. I'm saying add my traces, a tracing ability to the application. I need to tell it what service name would be and stuff like that using the resource builder. And I enable the sampler, we will talk about it a bit later. And I say do not sample anything. I want all the data ingested to my tracing kind of, target, sync, or whatever. And I'm adding Zipkin exporter. Zipkin is a very lightweight tool that I run in Docker container just to show traces on the screen. And for metrics, I do a similar thing. And that's brand new. It didn't exist before like 2 months, and it's still in beta, I think, the metrics part. But the instrumentation of apps and libraries using abstractions from system diagnostics, it's not in beta. It has been released 1 month ago when they released .NET 6. And the library they provide, it actually has support for .NET 5 and 3.1 and probably even .NET Framework. I don't remember. But here I'm adding Prometheus exporter, so I won't run Prometheus. I will show you just metrics on the screen in text and explain what it looks like. And then I have a very simple API. That's just a controller, right? Which gets this instrumented service, like some service, whatever, repository, application service, anything that does some work that involves some I/O that goes to the database as such. And it has some delay. So the service does the job, and you can see what kind of job it does. It just randomly times out, or not times out, just waits for a few seconds, up to 100 milliseconds. So now I want to know how my service behaves, right? I want to see how much time it takes for the request from the controller to pass through my service and get back. So I want to instrument it. All right. So what do? I created a few things here. First of all, I needed to do this thing. It's just the basic stuff, right? OpenTelemetry sets certain requirements on how your application needs to report instrumentation. They want to know what the application kind of is called. It's the instrumentation name. They call .NET, OpenTelemetry.NET. Everywhere uses this assembly name, right? But you can just write any string as soon as you can find it in your APM tool. And they want a version. So again, they use assembly version. In this case, I don't have assembly version at all. So it probably will be either empty or 000. But it's useful because you actually want to know which version of your app has delivered this trace or metric, because otherwise you couldn't distinguish them. Maybe there is one version and other version running and stuff like that. So I basically could have used assembly name because it has a name inside, but I call it my precious because I like Lord of the Rings. So that's it. This one, we get back to this later, and this is actually about metrics, and it uses this thing with system diagnostics metrics, which is brand new and shining and stuff like that. So let's move to traces now. The nice thing is that with all the work that Microsoft has done so far, remember this thing. First, there was this event source. Who remembers the event source? Quite a few. Okay. Remember what it was used for? Push kind of pseudo logs to event log in Windows, right? It changed a little bit, and actually, if you say, I want to listen to certain event source is actually an observable, and you can attach an observer to it, so it's a decoupled thing. So it's actually in some ways a bit better than Microsoft login abstractions, because if you don't listen to the observable, it doesn't do anything, basically. It doesn't report anywhere. So, and it's completely decoupled. The bad part is that sometimes, no, it's about activities. Sometimes if nothing attached, you don't see anything, but it's kind of normal. I think I'm saying something wrong. Okay, nevertheless, if you don't listen to it, it doesn't do anything, so it's good. And next thing they've done, they created diagnostic listener that implemented the abstract class of diagnostic source, which was pretty confusing because you have a variable saying diagnostic source and you instantiate diagnostic listener. And the type that it returns to you is diagnostic source. So it's like, for me, it was always confusing. The point with diagnostic listener and the source and the adapter to it, they have a package with some attributes that you can publish events a bit differently. So you can wrap it in nicer API and things like that. And you, again, can attach the diagnostic listener to your diagnostic listener, which is a source, which will report events to you and see things. But diagnostic source allowed you to attach a kind of arbitrary payload, a kind of pass HTTP context to it, which event source couldn't do, because event source serializes things to string, always. And that's how we got the first primitive traces, actually. So we attach using observers to that source and say, okay, now it started and now it's ended. Then they introduced activities. And when people started to implement activities, they said, that's legacy. We move to activity source now. And activities produce diagnostic events that can be listened to by diagnostic listeners. By conventions, it's something started and something stopped. So if you spin up an activity and start it, it will produce an event for diagnostic listener that's called activity name.started by convention. And then when activity stops, it will produce a diagnostic listener event that's called activity name.stopped, which is confusing, but still it's like this. And the activity source is just an attempt to make the whole thing, the whole story with activities, much easier to work with. And this is what I'm using now. So, I create here in this class, that's called MyTraces. This class is considered as an instrument by OpenTelemetry. And this class needs to be put somewhere so it gets instantiated because it's not static. And it creates an activity source that I call source. And it uses the instrumentation name that is predefined over here, my precious. And it uses the version, which is the assembly version, which is probably null. And of course, it can be disposed. So the activity source is a shortcut to create new instances of activity that actually wrap the execution of certain long-running operation. With long-running, I mean 10 milliseconds or whatever, but it's still not like it maybe involves some I/O or stuff like that. There's not nanoseconds. So how can I use it in my app? Not in my app, but my instrumented service. So that's actually pretty simple. I say using var activity equals, oh yeah. So first I need to get this as a reference. Public instrumented service, my traces, and I need to have this as a field. And then I can say traces.source.start activity. And that's actually it, because it has a parameter which is using the caller name as a name of the as a value, right? It's called caller name or something like that. It's an attribute. We can specify, because the first parameter is basically the operation name. We can specify it explicitly, and we can have some sort of convention. But if you omit it, it will just do the job as the activity name. And that's it. What this line would do, it will start new activity. What activity does? When you create an activity and start it, so activity itself has this API, which you can see. Who used activities at all? That's pretty useful. So it's a disposable thing, of course, because I have using here. And it has all the stuff that you would need to associate it with a certain trace, right? It has a span ID, trace ID, parent span, the baggage, diagnostic events attached to it, status code, and stuff like that. But interesting enough that by the end of execution of this method, the activity will be disposed. By that time, like when it disposes, it stops. And when it stops, it reports how much time it took for the activity to run. And if you listen to activity.stop diagnostic event, you can also extract the duration of your operation, which is in our case very useful. So doesn't seem like much, but we can do something with it now. Interesting stuff about activities that after I do this, and when I start the activity, I have access to this thing that's called activity.current. Activity.current would be equal to the activity instance I just instantiated. They put it in a sync local context. So everything you do in your method and below will be within that async context. So in some other place, you can use this activity current and attach to it as a parent activity, but we'll see how it works. So enough code. Let's see how that actually works. It's not enough, of course, because I instrumented my library, but it doesn't mean that it will report any trace to the application. The application itself needs to know about this instrumentation. So what I do, I already have this stuff, right? I need to do two things. So first, add instrumentation, my trace, right? When you add it like this, it will try to resolve it from the service provider. So it means that I need to register that as well. Services add singleton. My traces. It doesn't have any parameters on the constructor, so it will be just instantiated. And then I need to say add source and then give it the activity name. So it's a measures instrumentation name. So basically, if you instrument your library in a very lightweight fashion like this, and this, I think it will work. So let's try it out. What I have here is that I have a Docker Compose, which runs some infra, including Zipkin. So let's see how it goes. So this is my test stuff. I have to try it out and say put something, and it just delays randomly, and then it returns done 10. The 10 I put here. And if I go to Zipkin, this is a scary moment for me because I tried it many times and sometimes it didn't work, but it worked this time. So this is the service name, payments, right? And this is the done job thing, and it has the library name my precious. And how much it took to run this service is 23.9 milliseconds, and that's the thing between 0 and 100, the time of my delay. Okay, now we know how long it takes to execute the service, so we instrument it within the library. What else can we do? Well, we probably need to put it in the context of HTTP execution because we're talking communication, right? Distributed systems. So, and then this brilliant work that people have done with OpenTelemetry for .NET will help us a lot. So what I need to do now, and I would say just add ASP.NET Core instrumentation and see what happens. Let me close this, and I will do 20, execute, go to Zipkin, find a trace, run the query, and I get this. Voila. So the first thing that happened is the HTTP call coming to us using method get, localhost 5050 as a host, the route, the response, the target, even the URL. Maybe if you have some secret information here, you shouldn't record it, but that's what OpenTelemetry package does. You see here is the name. And this is our service. How this magic actually happened, because we never associated one with another. This happens using that thing that I told you, the activity when it gets started. We do have it in a sync local context. So what happens is, when you say activity.start, it will see, do I have something in activity.current? And in the previous example, it was null, so it was just one thing. And in this case, when I have HTTP call, OpenTelemetry instrumentation for ASP.core, it started an activity already. So when my service starts the activity, it attaches my activity to the one that's already running. So it kind of builds the parent-child relationship between them. And then I see this, right? So what can we do with this? I will show you a gigantic span or trace afterwards, but important thing is that this is a trace, right? And every operation within a trace is a span. And it can't cross the boundaries of a single service. To do that, you need to propagate the execution context. You need to, let's say you make an HTTP call to another service. When you do that, and there is instrumentation for OpenTelemetry for HTTP client and for ASP.NET Core, like we see, they will put the current activity span ID and trace ID to the headers of that call. And when the other side receives it, they will retrieve it and spin up a new activity and use it as a parent. So in this case, everything lines up and you get gigantic traces with a lot of spans. I have it working, so I will show it later. But for now, what I want to say, okay, what about metrics? Because that didn't work at all. There are two ways to instrument your thing with metrics. Basically, we got this new thing in this system diagnostic metrics namespace that's called meter, this one. And meter doesn't do anything. It doesn't build Prometheus metrics. It doesn't do much. It's basically a proxy thing. It's an abstraction for the implementation to collect data for metrics, right? So it passes through, but it gives you a nice API. So what a meter can do, using the meter, which I now create using the same instrumentation name, you can create, for example, a histogram metric. In this case, I create a histogram of type double. That's called duration. This is the description of things. And this, it's not description, it's a name. And I give it a unit, so it's in milliseconds. So now, what do we need to do with it? Why this stuff exists? So there are two ways of basically collecting metrics. So one way, if I would be doing the same as here, I will create a class, disposable, that will instantiate a meter, create a bunch of metrics, inject this class to my service, and wrap up the execution of my long operation into time watcher or something like that. So then, by the end the execution finishes, I will get this time and report to the metric. But I already measure it using the activity, right? An activity has a duration, I told you. We just not used it. So what you could do is to create this nice thing that's called activity listener. Activity listener, you can create it yourself at any time, and you specify up to 4 functions. So first function is deciding which activity I need to listen to, which activity source I need to listen to. The second one tells how to sample this. In this case, I don't sample anything. I want all the data. And there are 2 more delegates. One is activity stop and activity started and activity stopped. And these functions will be called for every activity that fits in these 2 conditions when it starts and when it stops. It allows you to fetch data about anything that happens in the system which is instrumented with activities. I'm not interested in activity started because it has nothing for me, but activity stopped already has a duration. So what I'm going to do, I create this listener, and this is a static thing. It says activity source add this listener, right? It's again the observable. And activity stop will do a very simple thing. It will take the histogram I just created and record the duration in milliseconds. Which means that is not this, I don't need to get this class to my instrumented service. It will just work if I keep instrumenting my app. So what I do here, I already have metrics here, so let me do this. Add instrumentation, and it will be my metrics. I still need to register though. And then I need to say add meter. And I need to say measurements, instrumentation name. So you see, it's kind of convention-based because it's all based on observables and observers, and all these things like, should I listen to that? Where is it? Over here. See? It kind of checks. And the meter has the same name. So it's kind of decoupled, and it's nice because you don't need to have a lot of things from system diagnostics inside a service, except of instantiated activity. So 2 lines of code I've done. Let's run it and see what happens. Let me close it, execute a couple of times, and then I can go to the metrics endpoint because you've seen that I enable Prometheus exporter. Prometheus exporter, of course, I need to add a server that exposes, oh, it's already here. It has a Prometheus scrubbing endpoints. 500. The demo effect, of course. I'm not sure what I'm running now. I think it's the right one. No. So I have no idea why it doesn't work because it worked 10 minutes ago. No. 50-50, is it correct? Yes. Nevertheless, you have to believe me that it exposes Prometheus metrics properly. Maybe because it's a release candidate. Actually, everything here seems to be instrumented correctly, unless I forgot something. No, it actually all is fine. So, no, it actually worked. I can do one thing here to just confirm if it works or not. Without my instrumentation, I can say add a SPNAV core instrumentation, because that's not custom, that's default. And I can run it again and see if they give me anything at all. And they don't. So I guess that's not my fault, then. I can blame Microsoft for that. Yeah. That's kind of sad, because metrics are good. Nevertheless, so let's see how this whole thing works in the real, like more, how to call it, more comprehensive distributed system. Let's just comment it out, all of it, and gets to something that I have from before, like this. I open telemetry and add services, and I skip the rest, right? And I need to run another one, which is the booking thing. So let's, oh, that's why. Something is badly wrong on my machine. Let's see if it runs. Payments. Some leap instrumentation, every single time instrumentation service cannot my traces. Yeah, I need to keep this one. Okay, my matrix. Okay, it works. Oh, I have too many Swagger windows here opened. So let me try to do some distributed thing. So I have one service running here, which has some operations. And it's an event source system which produces events and stuff like that. So let's just create a booking and a guest ID and whatever, and then put the dates, 100 euro, and execute it. Should work. So let's see what's in Zipkin now. Find a trace. And this is the one, right? And it already exceeds what we ever experienced before. It has a lot of stuff, because that system is way more distributed. There is an HTTP call coming in, there is a command handler, there is event store append, and there is a consumer on the other side that projects it to Mongo. So here in this system, there is an operation going outside of the single thread of execution. So the HTTP command gets handled, and then afterwards the event gets projected to Mongo database, and you will see them all independently. However, they're all connected in a single trace, right? And you can see that this operation, HTTP handler already returned the results to the browser, but the operation is still ongoing because it spans over the execution of HTTP call. If we run now this guy and say we record a payment, which is another microservice of sorts, and use like 100, this is the payment microservice that does its own thing, so everything is right, and then we go find a trace, and let's just run it again. Consume. That what was supposed to happen. So enable to read events from 1 to 3. Yeah, I need to do it again. 3, 4. And we will look at those separately. So this is the operation that happened with an error. So when you have an activity, you can tell the activity to set status to error, and in proper APM tool, it will be shown as an error. And you can see exceptions and everything attached to it if you do it correctly. OpenTelemetry itself has quite a few extensions for activity class that allows you to record exceptions. So you can use OpenTelemetry SDK for that. Or you can use just your own thing. The only thing you need is actually set a bunch of tags. And apparently, most of the APM providers can understand this. So these names are important. If we still now look at the successful operation, you can see, here we go. So that goes from between two services, we have some kind of collaboration, I believe. So here you can see that the single operation exceeds, like I said, the execution of a single command. It goes to other services and stuff like that. What I can also look at is the service dependencies. Payment's supposed to be here, but never mind. So it has the booking stuff, and it has localhost 2113, which is event store, and it has localhost 27017, which is the MongoDB. Datadog shows it nicer, and AWS X-Ray shows it much nicer. But this is a primitive thing, already shows the power of distributed trace because it tells you how services talk to each other. How you propagate the context. If you look at the message that I posted through the wire, I propagate remote context by setting certain tags and metadata. Like, think about headers in HTTP requests and stuff like that. So you need a span ID, you need a trace ID. These things you need to get over the wire to the consumer. And then they will be able to create their own spans and connect them together, and everything looks fine. So what OpenTelemetry does in addition to that, they have an ambition, because you see, someone worked with Prometheus, right? I failed to show it. So Prometheus metrics are exposed in text, and Prometheus is a pool-based metric collection. So you instruct Prometheus to pull certain data sources. It goes to the data source, usually like something /metrics. It's usually open. Does it support authorization? I don't remember. We usually close this endpoint only for internal use. Prometheus call this on schedule, like 5 seconds, 10 seconds, stuff like that. So it's not like app metrics. If you ever worked with app metrics, it continuously accumulates things and then decides to send it somewhere. And it's not like StatsD. StatsD have a completely different protocol. They use UDP, and they can continuously push metrics. And in order not to overload the receiver of metrics, they sample them. Prometheus doesn't really sample anything because it is what we call observable metrics. They call you, so you need to accumulate those metrics, and you need to expose them when the time comes, so when Prometheus asks for it. And it's a text format. StatsD apparently uses UDP, and they use message pack. Elastic uses documents in Elasticsearch. You actually need to say index document, then it will go there and will provide you with enough information. Everyone uses their own thing, and that is kind of a problem. OpenTelemetry got this ambition to create a protocol, which is gRPC-based, supposed to be very, very fast, which will do all these things and get it standardized. So their idea is that there is a collector that can expose receivers in different formats, so they're even ready to receive data in Jaeger format and Prometheus format. They will push it through the metrics pipeline and traces pipeline and maybe even logging pipeline, and you apply certain things, like you can apply batching and sampling inside a collector, and you can create custom authorizations, you can create custom samplers, whatever, and put it in the collector. You run collector as an application, so it's ready-made. It's a Docker file, a Docker container. You can actually run it, right? And on the other side, you have exporters. And there are a lot of exporters right now, and I think the number of exporters will increase. So if you look at OpenTelemetry.net, for example, they have a bunch of exporters built in. And Zipkin exporter, Jaeger export, and Promise exporter, and some other Z pages, they are already in there. So you can just drop in a package and we'll export, like I've done for Zipkin. And for Prometheus, which apparently didn't work for some reason. But we use Datadog in ABAC. So like, what do? Well, we deploy the collector. We enabled Datadog exporter, which supports both metrics and traces. And we started to push our metrics and traces to the collector instead of putting it directly to Datadog. And it works pretty nicely because then it's really kind of vendor agnostic. We can push from the same collector, we can push somewhere else, like in Google Cloud or something like that. So how this actually works. I have the collector running. I will show you how I configured it. So let me stop this thing. Collector, I have a Docker Compose file. Yeah. You can see it's configured. This is basically not, there are two versions, of course. There is the OpenTelemetry collector and OpenTelemetry collector contrib that has a lot of exporters and other things. And I tell it to use my config file and it exposes the gRPC port. I think one of them is legacy, another one is new. It's always like that. They have quite a few breaking changes on the go. And the configuration file is here. And you can take a picture of my API key, but on the free plan, it will shut me down if you misuse it anyway. So it just exports to Honeycomb. Honeycomb is another thing that just accepts APM data. Basically, they can only process traces. I chose it because I can show it straight away how it works. So you can see here, we configure receivers. From the thing is that it is a collection, you can understand you can configure more than one receiver. OTLP means OpenTelemetry protocol, with that is generic protocol that it designed. And it uses gRPC and HTTP. We had a batch processor, so it will time out and collect batches by 10 seconds. You can do some health pages, Z pages, whatever, extensions. Normally, you could basically say, I want Kubernetes extensions, and they will collect some metrics around itself, and maybe put some tags that are default for that node. And here's the configuration for Honeycomb. For Datadog, you would have something else. For Google Cloud, you probably just set some environment variables. And I have one thing here, which is the pipeline. I had to remove the metrics pipeline because it crashed and said we don't support metrics, which is true. And then you say, for traces pipeline, I have the OTLP receiver, which is OpenTelemetry protocol. I have a batch processor, it's kind of pipeline in the middle, and I export it to Honeycomb. And I can also export it to logging, for example, and it will log on a console. So right now, when I have it running in my Docker Compose, I can say that let's just limit to something that actually works without promises and other things. Stop that. No, I actually can keep it. I can go to my add OpenTelemetry thing. And when I'm adding the traces, I already have this OTLP exporter enabled. And that's probably why I don't see traces from payment. Silly me. So when I was running this operation, so let me just do the same for the bookings, and then we see the full trace. It's the OpenTelemetry exporter. You see, all is done. These packages are available. You can just grab them out. And here I have also the gRPC protocol instrumentation, which is part of OpenTelemetry. And what I need to do in registration here, I need to replace the Zipkin exporter to OpenTelemetry exporter, which is this one. It's right here. Let's run them both. So now I'm not running any vendor library inside my applications. I export to OpenTelemetry own exporter, and it takes care of distributing my traces using their own protocols, whatever exporters that the vendors have provided for the OpenTelemetry contrib. So if I go whatever, 2, 0, execute that. Everything is fine. Honeycomb takes a bit of time to, because again, with 10 seconds batching and stuff like that, I have some traces already reported, but I can run a query and see my new trace came up. Yeah, it did. So that's the trace in Honeycomb. Let's see how it looks like. It looks a bit nicer than Zipkin. This first thing with the HTTP call takes longer because it's how Web API works. I think they resolve dependencies for controllers on the first call because they're kind of implicitly registered. If I do one more request here, I lost my browser, sorry. And it will be just another ID. And everything was fine. And let me try to do the payment because I think payment service reports to Honeycomb already. Record payments. That's too much. And then let's see how that will go. So I guess that was the second call, is the same one. Let's run the query again. Yeah. So that looks a bit more decent. Yeah. So this is what you get from a normal kind of APM provider, which is not Zipkin, because Zipkin is too vague. You have a lot of stuff. And when you start browsing through it, you have a lot of tags, and you can build new queries and things like that. And if you go to, for example, here, in a query, they give you a lot of different things, which you can kind of compose a query with, like routes, DB name, DB operation, and all the tags here are kind of default. There is a bunch of tags predefined. You can find them all as constants in OpenTelemetry library. They're part of the spec, I think. So when you instrument your library, you need to think about all these tags so other applications understand you. OpenTelemetry API library for .NET provides also the text map propagator. So when you need to push the metadata to the context of your HTTP call or something, or the other way around, extract it from it, you can use that propagator. But you can also write your own. You just manipulate the headers or extract data from headers. It's pretty easy to do. So they also suggest you some things. For example, this is raw data, right? And if you go, what the hell? Run the query. Yeah, Honeycomb, whatever. Maybe I'm not on a paid plan or something. They have a bunch of stuff. So Zipkin, for example, Zipkin shows you the service map, and Datadog shows you the service map. Shall I show our service map once, Martin? I won't. Can't stop me. This is production. There's not that we are very proud of what we have, because we haven't instrumented everything as we should. And I think with OpenTelemetry we have a better chance because they have much better kind of service name conventions and things like that. This stuff is instrumented with open tracing, as I believe, most of it, not all of it. And if I go to APM service map, so when you instrument your systems, you get something like this, but I can assure you, if you do it right, you will get it better, because we haven't done it right. There are a bunch of things that are not connected to each other, and there should be a gigantic thing right in the middle that's called legacy database. But it's not shown, so we've probably not done our job right, but we're going to fix it. The problem here that service names in open tracing are kind of vague. We assign, like, this is a legacy database for positions, this is a legacy database for customers, this is a legacy database for something else, because we use the service name itself as a prefix and a database as a suffix. And that's entirely wrong. When you instrument by default with OpenTelemetry, what you get is things like that, right? So let me run this query and show our spans. You see, it will use the service name provided in my code. See, this one, add service. When you do the service builder thing, it uses this over here. But when I do the remote call using the default instrumentation like gRPC or MongoDB, you see that it uses the host name of the target. And if you call the same host name, let's say my Mongo Atlas cluster or my gigantic legacy database, it will always be correct. And so you will see the gigantic ball of mud right in the middle that everyone is calling to because it will use the host name. And like, let's say I need to instrument it with HTTP client. Guess what? There is a HTTP client instrumentation library from OpenTelemetry. So that's pretty useful. Even if you don't want to instrument your own libraries, you can already use the instrumentation provided for you. And you will instrument gRPC, ASP.NET Core, or ASP.NET is also supported, or .NET Framework Web API is supported, even ADO.NET, Redis calls. There is a library that Jimmy Bogart wrote for OpenTelemetry that supports instrumenting MongoDB, which I use here. These are MongoDB calls. So it's just a matter of searching for it. And if we look at how many exporters they have in a collector, because you might say, okay, there is no exporter in OpenTelemetry for my APM provider. So what do I do? Well, you can use collector, right? And it's like, you see, I can scroll through this list. And I'm quite sure if you use some provider, you'll probably find it in the list. They have everything, I think. X-Ray, Azure Monitor, Google Cloud, Elastic, whatever. So, but if you don't do anything at all, which some of you admitted, so please start doing that because it will save your day and hopefully save your night, right? And you actually have to do it because otherwise you don't know how your system works. I think that's my last slide. I'm sorry for some things in a demo. It's always shaky when you do so much online coding, but I hope you got the idea. All right, that's it. Questions? Am I too early? No, I'm fine. Yeah?
So my understanding is that the OpenTelemetry for .NET exposes a .NET API, but you also, in the example you used, you're using the API from Microsoft. Are there any benefits by using either Microsoft API or the OpenTelemetry?
OpenTelemetry for .NET is built on top of the things that the .NET framework using activity and diagnostic source and new metric API provides. So they use each other. That's why in my instrumentation I only use the default things. I have in this service, this library which I instrumented. You can see the dependencies for it, and that's the only one. System diagnostics, right? I think in .NET 6 I can just remove it and still be referenced because it's part of the runtime. So that's the nice thing because you don't really need to take the dependency on that. What they have guidelines in OpenTelemetry.NET saying you would need to take a dependency on OpenTelemetry SDK, provided like the open source project, if you want to ensure that you use the same conventions and tags and everything, and you also want to use API that involves spans and traces instead of using activity. They are interchangeable because they use each other. And you want to use their context propagators, extraction and injection. But I personally, in the Ventures library, I wrote my own. It took me like 15 minutes. It's a dictionary string object. You just read from it using your own tags or their tags, and that's it. It's not that hard. I think by using activities and the new metric APIs, they actually did a decent job on decoupling things. So you don't need to take lots of dependencies to make it work. Because for instrumenting with Datadog, we have to take dependency on Datadog tracer. And we need to take the dependency on Serilog Datadog sync. So we still do it, but when they implement logging, we won't remove it as well. So and everything will go through the collector. So yeah.
we tried to use that, and it didn't work well. Well, we tried Jaeger with excellent results, and we tried the same code with Elastic, and we didn't get as sort of nice diagrams, and some things didn't really work at all, like spans. So our impression was that it really depends on what you use, what exporter you use. So from your experience, what you would recommend to use as the best thing for distributed tracing?
Well, we use Datadog. I don't work for Datadog, and they pay me, so I wouldn't recommend Datadog, but it's a really nice tool. It's like the problem with Datadog that I found is that it doesn't play nice with .NET to the extent I want. So, for example, they provide native OpenTelemetry instrumentation for Java and Python, I think, but they haven't done it for .NET and say just go to open tracing, although they know it's obsolete. But we work around this using the exporters. So I think it doesn't really matter if it's OpenTelemetry or not. It's just search for the best APM provider that gives you the most value. What I liked about Datadog, I can show you this. This is very nice. I'm not sure if other providers do the same. But these guys, let's have something like this. Like I go to the homepage. It detects stuff, you know, and this is the APM. This is a trace. It says that latency was up for more than 4 hours yesterday, and this is unusual change in throughput monitors. They actually have some advanced AI that detects things like that. And if I go to that service, I will see that these are things, and I can look on correlations between stuff like memory usage and the error rate and the hit rate and whatever, because it correlates logs from the infrastructural metrics like CPU usage and networks and whatever, and can consolidate them all in a very nice overview. And they even, like, if I use their own Serilog sync for Datadog, and I have tracing enabled, and I think we wrote it ourselves, actually. So we use Datadog Serilog sync, and we have activity running. We just say everything we log within the context will get a span ID and trace ID, and Datadog can correlate traces with logs. And if you get error trace, you click on it, you see the logs below. It's really nice. I think most of the providers do the same. It's just a matter of how it kind of works all together. So if I look at, no, not trace, services list, and let's take this one, which is not that good. If I click on this one, I think this is the most brilliant thing ever. I'm a lazy person. I don't want to figure out what monitors I need for that particular service. They say we have 6 suggested monitors, and you can decide which one you want to enable. And if I enable one, they will tell me if something goes wrong. And they have a bunch of ways to tell you, like the simplest would be Slack, and another would be PagerDuty integration and Opsgenie, whatever else, which is cool. And I can do that, right? Boom. That's it. I'm a DevOps person now. And I have a bunch of things to configure. And like, this is really good. And again, if you are in a single cloud, you might find that your cloud provider has very good tooling. If you're multi-cloud or you're on-prem, you might find out that like more a cloud-agnostic vendor like Datadog could provide you a better experience. Okay. Anything else? All good? Everyone wants to go for dinner and drink some beer. All right, thank you very much. Thank you for your patience. Thanks.